Hello everyone. Today we are going to discuss about the fourth problem, designing a DFA, that is deterministic finite automata for a string ending with 0, 1, 1. Let's start the deterministic finite automata fourth problem. Thank you.
Good afternoon, everyone. Today we are going to discuss about the next problem, that is designing the DFA which accepts the string ending with 0, 1, 1 over an alphabet sigma equals to 0 comma 1. Okay, so which accepts the string ending with 0, 1, 1. So first we should, by seeing this particular question, we can understand that any string ending with 0, 1, 1, that should be accepted. So the basic string, according to our discussion in the earlier videos, we have already discussed that string ending with 0, 1, 1 means 0, 1, 1 will be at the end. Before that we can have any number of zeros or ones. So ending should be 0, 1, 1. So before that, we can have any number of zeros or ones. So basic string for this particular question, according to our question, what it says, design DFA, which accepts the string ending with 0, 1, 1. So ending string should be 0, 1, 1. Before that, we can have any number of zeros or ones according to the given alphabet, sigma equals to 0, 1. So the basic string what we will get is that is 0, 1, 1. This is the basic string. So before this we can have any number of zeros and ones, means we can either have 0 or we can either have 1 or we can have any number of zeros ending with 0, 1, 1 or any number of ones ending with 0, 1, 1 or a combination of 1, 0, 1, 0 ending with 0, 1, 1 or a combination of 0, 1, 0, 1 ending with 0, 1, 1. Okay, so we can have a combinations like this. We can also have a combination of 1, 0, 0, 0, 1, 1, 1, but ending should be 0, 1, 1. So before the 0, 1, 1, we can have any number of zeros or ones that can be there. This is our question. That's what our question says. So we have to design DFA which accepts the string ending with 0, 1, 1 over an alphabet sigma equals to 0, 1. Means our entire string should contain zeros and ones only. So whatever that is there in the alphabet, the string should be or will be the combinations of zeros and ones only. So it should be ending with 0, 1, 1 means before this it can have any number of zeros or ones. So the basic string is 0, 1, 1, and after that we will take some sample of strings. So either it might be 1, 0 or 1, 1 or combination of zeros or combination of ones or combinations of zeros and ones starting from 1 or starting from 0 or any combinations are also acceptable according to our question. So if we are going to design any DFA means definitely it should be the string should accept, the DFA should accept only this type of strings. Okay, so whenever we are going to start a DFA, definitely we should take the basic string to define a simple finite automata. Upon that, we will try to design more states and transitions depending upon the examples what we have taken. Okay, so now the basic string we have is 0, 1, 1. So start from the initial state. So I am starting from the initial state, that is Q0. First symbol is 0. Second symbol is 1. Third input symbol is 1. So this string should be accepted. So this we know, right? How to design a finite automata for a string, that we know. Start symbol should be 0. Next will be 1 and next will be 1 and it should end. So we should try to design a finite automata which accepts 0, 1, 1. So that is done. But our question asks not only 0, 1, 1, a string ending with 0, 1, 1 means before 0, 1, 1 we can have any number of zeros or ones. means before this 0, 1, 1, we can have any number of zeros or ones. But if you take a DFA, a state should have a transition with only 0 and 1. Okay, it shouldn't have more than one transition also. So that is the definition of DFA. DFA means each state should have a transition over these two symbols, and it shouldn't have more than one transition. Suppose if you take Q0, so if you take Q0, it shouldn't have more than one transition with same input symbol. So this is wrong. It should have only one transition with 0. It shouldn't have more than one transition according to the definition of DFA. So each state should have a transition with 0 and with 1. Okay. With same input symbol, we shouldn't have more than one transition. Yeah, this is wrong. It should have one transition with 0 and one transition with 1. That is the definition constraint. So according to the definition, Q0 is having 1, 0. Q0 should have a transition with 1 also. So I can make a self loop with Q0. I can make a self loop with Q0 over, input symbol 1. Okay. So with input symbol 1, I can make a transition. Okay. So now we can have any number of ones before 0, 1, 1. So 1, 0, 1, 1. I can have any number of, see, check here, we can have any number of ones ending with 0, 1, 1. So that satisfies any number of ones, 0, 1, 1. So ending should be 0, 1, 1. Before that, I can have any number of ones. So I can put a self loop to Q0. Okay, so now 1 is accepted. So Q0 is having transition with 0 and 1. That is done with Q0. Now if you go for Q1, Q1 is having a transition with 1. It doesn't have a transition with 0. Can I put a self loop to Q1 over 0? Is this possible? Yes, because I can have any number of zeros before 1, 1, right? So 0, any number of zeros followed by 1, 1. This is acceptable because anyhow the string should end with 0, 1, 1. Either it might be this 1, 1, this 0, 1, 1 or this 0, 1, 1. Okay. So that's why we can have a transition with any one of this. Now putting a self loop for Q1 with 0 is acceptable because the string should end with 0, 1, 1. That is done. Now Q0 is having transition with 0 and 1 and Q1 is having transition with 0 and 1. Now Q2. Q2 is having a transition with 1. It doesn't have a transition with 0. If I put 0 here, then the string will end with 1, 0, 1. That way it is accepting 1, 1 and also it has a capability of accepting 1, 0, 1. So I can't put a self loop for Q2 with 0 input symbol. So we can't put Q2 on 0 to self state. We can either put a transition from Q2 on 0 to Q1 or either Q0. Anything is possible. I can able to make a transition from Q2 to Q1 on 0 or Q2 to Q0. I should check which is acceptable. So if I take a input symbol like 1, 0, 0, 1, 0, 1, 0, 0, 1, 1. If I take this string, it should be accepted because it is ending with 0, 1, 1. So this string should be accepted. So in order to accept this, we have to check which transition is better. Whether Q2 to Q0 I should make or Q2 to Q1 I should make. If I make a transition from Q2 to Q1, then 1, 0, 0, 1, 0, okay, again 1, 0, 0, 1, 1. It is acceptable. So I can make a transition here. Suppose if I take a string like 1, 0, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1. So this string should also be accepted. Now we will see 1, 0, 0, 1, 0. So let's take 0 is having a transition with Q1 here. So it will come back here 0 and again 1, 1. it is ending up with 1 1. So we can't able to make more transitions with more having more number of ones. So better make a transition from Q2 to Q0. Okay. So we will check with that particular transition Q2 with 0 as an input symbol with 0. So I can make a transition with Q0. Next, if you take Q3, Q2 on 0 1 we made transition. Now check for Q3. Q3 shouldn't end up with 0 or 1 because it should end with only 0 1 1. So we can't make a self loop with any other state. So Q3 with 0 and 1, it should move back to some other state. So with 0, we can make a transition to Q1, 0 1 1. It will end up. So we can make it as transition with 0. Whatever we do, 0 1 1, 0 1 1. Finally, it will end up. With one's transition, we have to go to Q0 only. Because here if I come 1, if I take a transition from Q3 to Q1 with 1, it will end up with 1 1 1. So that is not acceptable. So better take from Q3. If it is 1, directly go to front. So better you put transition to Q0 only. Okay. So now if you check, Q0 is having transition with 0 and 1. Q1 is having transition with 0 and 1. Q2 is having transition with 0 and 1. Q3 is having transition with 0 and 1. One simple idea what we can do is 0 1 1 we already have. If it is 0, better put before this 0 1 1. That's it. If it is 0, better put before that. If it is 0, better put before 1 1. Okay. Now if it is 1, better try to take to Q0. If it is 0 only, you have to move it to Q2 and Q1 because it should end up with 0 1 1. 0 0 1 1. 0 0 1 1. Like that, you can either see both are acceptable. From Q2 to Q1 also you can make a transition with 0. That is not a problem. But for Q3, don't go for Q2 because it will end up with 0 1. So don't take that with Q2. Better make all transitions to Q1 only. That will be better idea of designing a DFA. Okay. So once again I repeat. So our question is a string ending with 0 1 1. So 0 1 1 means the basic string becomes 0 1 1. Based on that we will try to design the automata with 0 1 1. Next step is before that we can have any number of zeros or ones. With 1 there is no problem. So we can put a loop to Q0 with 1 transition. So Q0 on 0 1 is done according to the definition of DFA. Q1 with 0 and 1. We should have a transition. With 1 we have, I can put 0 self loop because it should end up with 0 1 1. No problem of putting self loop here. Now if you take Q2 with 1 we have with 0. I can't put 0 to self state because it will end up with 0 1. I can't. You can either make a transition from Q2 to Q1 also. That is also fine. Q2 to 0, it will become 0 1 1. It's good only. You can either take like this or like this. Both are correct. So I have taken to Q0. You can take Q2 on 0 to Q1 also. So Q2 on 0 1 we made a transition. Q3 on 0, you can't take it to self loop because it will end up with 0. Ending with 0 we don't have. It should end with 0 1 1. So next Q3 on 0 also we should make, it will end up with 0 1. So don't make a transition to Q2 over 0 from Q3. Q3 to Q1, it will end up with 0 1 1. So that is correct. Hence we can, with one's transition we can't go in the middle. Here if I put 1, then it will become 1 1 1. That will be a wrong. So better take a transition from the state Q3 over 1 to Q0 only. So that wherever I reach, it will end up with 0 1 1. So better take one's transition like this, zero's transition like this. So that finally it will end up with 0 1 1. Okay. So that is the main important thing we should know in DFA. The main constraint in DFA is every state in the finite automata, that is it, which is in DFA, the state should have a transition over each input symbol present in alphabet. So if I take a state, it should have a transition with 0, and so 0 1 1 means the basic string becomes 0 1 1. Based on that we will try to design the automata with 0 1 1. Next step is before that we can have any number of zeros or ones. With 1 there is no problem, so we can put a loop to Q0 with 1 transition. So Q0 on 0 1 is done according to the definition of DFA. Q1 with 0 and 1. we should have a transition. With 1 we have, I can put 0 self loop because it should end up with 0, 1, 1. No problem of putting self loop here. Now if you take Q2 with 1 we have with 0. I can't put 0 to self state because it will end up with 0, 1. I can't, you can either make a transition from Q2 to Q1 also. That is also fine. Q2 to 0, it will become 0, 1, 1. It's good only. You can either take like this or like this. Both are correct. So I have taken to Q0. You can take Q2 on 0 to Q1 also. So Q2 on 0, 1, we made a transition. Q3 on 0, you can't take it to self loop because it will end up with 0. Ending with 0 we don't have. It should end with 0, 1, 1. So next Q3 on 0 also we should make, it will end up with 0, 1. So don't make a transition to Q2 over 0 from Q3. Q3 to Q1, it will end up with 0, 1, 1. So that is correct. Hence, we can, with 1's transition, we can't go in the middle. Here if I put 1, then it will become 1, 1, 1. That will be a wrong. So better take a transition from the state Q3 over 1 to Q0 only. So that wherever I reach, it will end up with 0, 1, 1. So better take 1's transition like this, 0's transition like this. So that finally it will end up with 0, 1, 1. Okay. So that is the main important thing we should know in DFA. The main constraint in DFA is every state in the finite automata, that is it, which is in DFA, the state should have a transition over each input symbol present in alphabet. So if I take a simple example of a transition diagram, transition function. Okay. So delta of Q0 over a string. We will take a string as this one, small one, because we need more time for this transition. So I have taken very simple string. Q0 on 1. Q0 on 1 is Q0. So Q0, 0, 1, 1. Now Q0 on 0 is Q1. Now 1, 1 I will take. Now Q1 on 1 is Q2. Q2. The remaining is 1 that I will take. Now Q2 on 1 is Q2. So with this string, if I start with the initial state, if I am ending that with Q2 means, then the string is accepted. Okay. Suppose if I take one more example in which the string is rejected. So Q0, 1, 0, 3 ones I will take. Okay. Now Q0 on 1 is, check here, Q0 on 1 is Q0. So Q0, the rest part is 0, 1, 1, 1. Okay. Now Q0 on 0. Q0 on 0 is Q1. Now take the rest part, 3 ones. Now Q1 on 1. Q1 on 1 is Q2. So Q1 on 1 is Q2. We will take the rest part. Q2 on 1 is Q2. Q2 on 1 is Q3. So we will take Q3. Take the rest part, that is 1. Q3 on 1 is Q0. So it is not reaching to the final state. Hence the string is not accepted. Okay. In this way, we will try to design the finite automata in which it will accept and reject the basic or sample strings. Based on that, we will try to design the finite automata. Hope you understood the designing of deterministic finite automata. We will have more examples in my further videos. Try to like, share and subscribe my video. Thank you.